In this episode, we are going to install some LED strips in our kitchen. At a glance, it looks very easy. Get some LEDs, stick them to the bottom of the cabinet and connect to the power source. But as you get into it, other questions pop up, such as what color of light should I use? How many LEDs per meter I need? How can I control them? Can it be dimmable? How big my power supplies should be? To get answers to those questions, stay with me. The kitchen is a working area. You need a strong light, especially when you work with sharp knives. In many cases, the lamp hanging from the ceiling is not enough, and this is where LED strips come to rescue. LEDs can provide bright, colorful, and even customized light. As you can see, they are very thin. They do not consume electricity as much as traditional incandescent light bulb. They do not get hot, they are efficient, and they will last for about 50,000 hours. Before you're going to run to the nearest electronics shop or make the purchase via the internet, make a plan. Get a drawing of where you want to install the LEDs. Make sure that you have the proper installation for the design that you want. But this is not enough. LEDs have a lot of different parameters. A small change can make a huge difference, especially if you have tens of those little LEDs. The width of the LED strip can influence brightness, the width of the profile, or the voltage rating. On TME website, you can find LED strips from 3.5 to 20 millimeters.
Here we have the most common ones, 8 millimeters, 10 millimeters, and 12 millimeters. However, if you need a brighter light or you want to blind someone or yourself, you can use the 20 millimeter LED strip. Notice that it has two rows and it operates at 24 volts, not 12.
Before you're installing your LED strip into a specifically designated place, for example, a suspended ceiling, take some measurements and do not forget about the width of the profile. Just like the different sizes of packages that we have here in TME,
we have different types of LEDs or cases. The case mainly tells us about the diode's dimensions. For example, the 3528 LED means 3.5 mm wide and 2.8 mm long. Bigger cases usually provide a stronger light beam, but have higher power consumption.
All right. And as we can see here, you have 12 different cases to choose from, and the most common ones are 3528, 5050 and 2835.
But what is the difference between 2835 and 3528?
That's an excellent question. Could you answer it, please?
Okay. 2835 is a newer version and can withstand higher power levels, 20 mA versus 60 mA. The 5050 cases are mostly used for LED strips with RGB chips, as it's bigger and has 3 times the capacity of a regular 3528. Speaking of the amount of LEDs, the number of LEDs per meter in the strip is directly proportional to the power consumption and the brightness.
It is also true that densely populated LEDs will give more light and at the same time will consume more electricity.
Yes, but this assumption is only true if we are using the same LEDs. The amount of LEDs per meter starts from as low as 28 and goes up to 528. And as you can see, there is another difference, the light distribution.
For a higher number of LEDs per meter, the light will be evenly distributed. However, as the amount of the diodes decreases, at some point we will see them as individual light points and not as an even line. If you have such a problem, try mounting the LED strip inside the profile with a diffused cover, like this. Although it will decrease its brightness, which is determined by number of lumens per meter.
The brightness is mainly dependent on the number of LEDs per meter, which is the power consumption per meter, and the light output of the individual LED. Basically, the more lumens, the brighter the light will be. But how much light do you really need?
Well, I suppose it actually depends on your personal preferences, but to help you with the choice, we've prepared a short cheat sheet.
Running LEDs below their full power consumption may extend their lifespan. The power consumption also tells us how much power our LED strip consumes per meter. With it we can calculate the total power consumption of the system and select the proper power supply. Here are a few examples of how the case of the LED and the numbers of the LEDs per meter influence the power consumption of the strip. 60 LEDs per meter with a case of 3528 consumes 4.8 watts per meter. 60 LEDs with 50/50 case consumes 14.4 watts per meter. You can see 3 times as much because there are 3 SMDs in 50/50 cases.
If you consider mounting LED for decoration purposes, such as edge lighting or backlighting, or you want to mount the strips in naturally darker places such as a corridor or a bedroom, choose less powerful LED strips or RGB ones. If the purpose of the strip is to provide light for work and it will be mounted in naturally lighter places, such as the living room or the kitchen, consider more powerful strips. Because those LEDs are going to be installed under the kitchen cabinet and provide light for work, we should use a tape between 15 and 25 watts per meter. To optimize your search, the TME website has built-in smart filters for each product group. After applying the filters, you can browse through the specific products. For more information, you can go to the product specifications. For this project, we chose the 25 watts flexible LED strip that has 240 LEDs per meter.
It is also important to pay attention to the voltage of the LED strip. Some of the common ones are 12 volts and the 24 volts. The 24-volt LED strips have some advantages over the 12 volts, however, if you use compatible parts for your installation, there is no such a big difference.
Or if your LED strip is no longer than 10 meters.
The 12-volt LED strip have better customization during the installation. Some of the 24-volt LED strips can be only cut into segments of 6 LEDs, unlike 12-volt strips that can be cut into segments of 3.
The 12 volts is also more common, like in cars, where you have 12-volt batteries, so you do not need extra converters or equipment to install the LEDs.
Yeah. From the efficiency point of view, the 24-volt is much better. About 30% of the power consumption is dissipated as heat, in comparison to 25% in the 12-volt LED strips. Here is an explanation for you. The voltage drop on each LED is about 3 volts. In the 12-volt strip, we can fit up to 3 LEDs and a resistor. On the 24-volt LED strip, we can fit up to 7 LEDs. The power dissipation on the current limiting resistor is equal to the wasted power, which means 25% for 12 volts and 12.5% for the 24 volts. If we are talking about current, then for the same power consumption of LED strip, for example 24 watts per meter, the 12-volt LED strip consumes twice as much current in order to reach the same power level. This influences the wire gauge, power supply size, voltage drops, and the length of the LED, all in favor of the 24 volts. Larger current require bigger conductors, bigger power supplies, and shorter LED strips.
They also cause more voltage drops. If you are using a DC power source, the voltage gradually decreases as it gets farther from the power source. Here we can see an example of a voltage drop. We have a long LED strip and a DC power supply. As we go farther from the power source, the voltage starts to decrease, resulting in a dimmer light from the LED.
We can do more than that. Let's take a look at the structure of the LED strip. In a regular 12-volt LED strip, the connection is as shown below. There are 3 LEDs and a resistor connected in series, and a bunch of those sections connected in parallel. Usually the LED voltage is about 3 volts and the optimal current is about 20 mA for 2835 LED cases and 60 mA for 3528 LED cases.
Okay, we got it! But probably most of people want to know how to fix it. So, if your LED strip is going to be longer than 10 meters, I suggest using a 24-volt LED strip as it's more efficient. However, if you still want to use a 12-volt LED strip, you can divide it into 2 parts and connect them in parallel using an extra wire. You can also connect the LEDs with the power supplies from 2 different sources or connect the power supply in the middle.
If you need to add extra wires, make sure to use the ones with a proper wire gauge. To find it, you first need to know what is the maximum current draw and then compare it with the table. For this example, let's use a 10-meter strip that consumes 6 watts per meter. 6 watts times 5 meters will give us 30 watts. divided by 12 volts, and we get a maximum current which is 2.5 amperes. From the table, we can see that the proper gauge should be around 16.
Don't worry, we did not forget about the kitchen. We will get back to it as soon as we finish with all these parameters. LEDs are powered by a DC voltage. This is not the power that you get from your outlet. Therefore, you need a power supply that will convert the AC to DC voltage. In other words, the input voltage should match the outlet voltage and the output voltage should meet the LED voltage requirements. Some of the power supplies have an additional feature, triac dimming. In this installation, the dimmer is a triac and it comes before the power supply, attached to the natural or to the live wire, like here. When you are choosing a proper supply, it's a good rule of the thumb to make sure that the total power consumption of the LED strip is at least 20% less than the power supply capacity. You should never use a power supply that provides the same or less power required by your strip. Here is how we calculated the power wattage of the power supply for our LED strip. We wish to install a 3.5 meter long strip under our kitchen cabinets. The strip consumes 25 watts per meter. Multiply 3.5 by 25, total is 87.5 watts. Then we multiply 87.5 by 1/2, which gives us 105 watts. If the power supply runs at its maximum capacity, it will heat up and die out quickly due to wear and tear. If you want to have more control over your LEDs, you should consider installing a dimmer. The dimmer is one of the reasons why we are able to install such bright LEDs. If it is too bright, we can dim them, and if it is too dark, we can lighten them. The dimmer also gives you the possibility to control LEDs with remote control.
If you consider RGB LEDs, replace the dimmer for a controller that will also enable you to change the light parameters with a remote and fade through different colors.
On the TME website, you will find many different dimmers with different functions and parameters that will suit your installation. When you install the dimmer, make sure that it goes between the LEDs and the power supply and it can provide enough current to your LEDs. The dimmer we chose is a simple one because we have only one color and it can supply up to 10 amperes, which is more than necessary for this installation.
But this only one color has character, and by character we mean temperature.
As you can see here, we have three main whites. A warm white that goes from 2700 up to 3000 kelvins, a cool white which goes from 3500 up to 4100 kelvins, and cold white that goes from 5000 up to 6500 kelvins. Basically, as the temperature increases, the light becomes bluish, or as we call it, colder, although it has nothing to do with temperatures. Warm colors are more suitable for living rooms where we want to create cozy atmosphere. Cold colors are more suitable for hospitals, bathrooms and kitchens. If single white color of LED is not enough, you have other possibilities. Monochromatic colored, the whole strip will shine with a certain color. White variable, you can change the temperature of each of the light of your strip. RGB uses red, blue and green diodes to display any color you want. Programmable LED strip, you can control each LED individually, and if you need more info about them, go to this video.
For more demanding projects like jewelry, you must consider CRI. Color Rendering Index tells you what is the ability of the light to show true and vivid colors of the objects compared on how they look in natural, bright sunlight. CRI goes from one monochromatic color up to 100 natural, vibrant colors. LEDs with CRI between 80 to 100 will show colors most accurately. You can also watch our video under this link.
The beam angle tells you about the effective range that the LED chipset emits light in. The value is given in degrees. The higher the degree, the wider the light distributed. The most common viewing angle for LED strips is 120. At this angle, even if you put the strip in a tight place, it will still provide great illumination. Speaking of demanding projects, if you want to mount your LED strip in the place where it can suffer from moisture, like bathrooms or outdoors, carefully check the IP rating of the strip. IP rating tells us under what conditions LEDs can operate and its protection against intrusion, dust, accidental contact, or even water. The higher the IP rating gets, the more stress your LED strip can handle.
Some of the LEDs are covered with gel cover. This provides a high IP rating, but be careful with that. Some of them have the gel cover only from one side. The other side, the one with the adhesive, is not protected from environmental conditions. So, do not rush and buy the one with gel right away. Check first its IP rating and if it has gel cover from both sides. While the LED strip might have a high IP rating, the connection that you make with the power supply might not. So make sure the power supply stays in proper conditions or have a high IP rating as well.
In order to give our LED installation a professional look, we are going to install LED profiles. LED profiles will all protect the LEDs from damage caused by people working by. It will also prolong the lifetime of the LEDs by acting as a heat sink, maintaining an optimum ambient temperature.
Another solution is to use rigid LED bars. Those will prevent hot spots and increase LED's lifespan. Some of them are made of ceramic circuit board or metal core PCB that has faster heat transfer than the regular ribbon LEDs. However, you should remember that they are not as flexible as ribbon LEDs.
There are a few main types of LED profiles. Surface mount, ideal for small areas. Angular, designed to fit any 90-degree corners and shine out the light from an LED at 60 or 30 degrees. Recessed, can be recessed mounted.
But not every LED strip will fit into every profile. Check if the width of the LEDs is smaller or equal to the inner width of the profile. The profiles can be in different shapes and colors. Once again, make sure that your cover can be mounted on the profile. Check its version or application. For the profile, you will need other accessories such as covers, connectors, and caps. We will talk more about them during the installation.
What will you need for your installation? An LED strip, extra wires, a power supply, a dimmer, an LED profile with accessories, a metal cutting saw, sharp pair of scissors, adhesive tape and screws, a drill driver, and a measuring tape. The link in the description below. The first step is to measure the length of the LED strip. They come in rolls like that, but don't cut them just yet. You need to find a specifically designated place to do it, otherwise they just won't work. Do the same for the LED profiles, measure and cut. Because the profiles are made of aluminium, it's very easy to cut them into smaller pieces.
After cutting, you'll probably need to connect those LED strips into a controller, to a power supply, a wire, or maybe another LED strip. And there are two ways to do this. Either you solder or you don't. If you have a soldering station and some experience, you will have good lasting connections. However, those are SMDs and they are pretty fragile compared to a through-hole components, of course. So you might burn them, especially if the connections are very short.
When you solder, use low temperature and do not keep the iron tip too long on the strip. Otherwise, you will burn the LEDs faster than you are able to save TME. This specification can be found on some of LEDs like here.
To make it easier, apply a small amount of solder on the two conducting points and then preheat the wire and apply pressure to it. Do the same on the other side.
The other option, the not soldering one, includes a crimp connection or a snap-on terminal. If you use a crimp connector, make sure to have a proper crimping tool. The easier version then, the snap-on terminal, doesn't require additional tools. However, you need to pay attention to the width and the number of connections there. Generally speaking, there are 4 connection spots for the RGB strips and 2 for the white LED strips.
In some cases, you can also use a terminal block for connecting 2 or more wires. For example, we can use this controller. To connect the wires, first you need to strip about half a centimeter of the insulation.
Then you need to insert it into the proper terminal and use a screwdriver to tighten the bolts. The terminal connection allows you to connect 2 or more wires to the same source. The
This is very helpful if you need to make few connections in parallel. Connect the controller or the power supply to one side of the block terminal. To the other side you connect the LED strips. Just make sure they match, ground to ground and 12 volt to 12 volts.
In our installation we need two terminal blocks, one on each cabinet to split the wires. Let's connect the power supply and the dimmer. Make sure that there is no electricity in the mains. There is a live voltage that can kill you. Go to the circuit breaker panel and turn off the section that you are going to work on. Now, after you made sure that there is no voltage, connect one side of the power supply to the mains and the other to the dimmer. For this connection, we can use a simple screw terminal block. It gives us the possibility to change the dimmer in the future. The other side of the dimmer goes to the LEDs.
As mentioned before, when you have a very long LED strip, let's say 10 meters, you can connect two power supplies, one from each side. This will solve the voltage drop. Moreover, most of the 12 volt LED strips go up to 5 meters. This is the recommended length from the manufacturer. Do not exceed this length. It can also be sometimes 4 meters and in some cases 3 meters. If we want to connect more than 5 meters, split the connection into two parallel ones and add an extra wire like here.
For the right side cabinets, we are going to connect the two with 90-degree connector. When choosing a connector, make sure it's compatible with the type of profile that you have. The 90-degree connector or the L-shaped connector comes with two mounting plates and screws. These make sure that your profile is stable.
To connect the two profiles, first check the place and make a mark where you're going to mount it, although this should be already in the plane that you made. Secondly, insert the two mounting plates. Thirdly, screw the two little screws to the surface. And finally, you can connect the two profiles from both sides.
To connect the two LED strips inside the profile, we are going to solder two wires. Make sure that you solder ground to ground and 12 volts to 12 volts. If you chose an LED strip with gel cover, expose the contact pins before you solder and do not touch the yellow part of the LED. Because we want to hide the wires as much as possible, we are going to drill a hole at the back of the profile and insert the wires through it.
Pro tip: check the position of the hole twice so you won't make the hole on the opposite side of the profile.
Like you did. Now all that is left is to insert our frosted covers into the profiles and seal them with caps.
If during your installation you do not use a profile, LED strips come with a pre-attachment tape so you can attach them directly to any surface. But remember, it might cause some heat transfer problems or will reduce the lifespan of your LEDs.
3M tape can be very strong but still affected by the environmental conditions such as humidity and temperature. With high humidity and temperature, the adhesive will slowly lose its bonding properties and then eventually fail. The surface to which the LED strip is attached also plays an important role, especially when we think of how long it may hold. Rough surfaces or those that have a special coating or finish will reduce the contact area or can be impossible to stick at all. So make sure that the surface is smooth, dry and clean before you stick them. On the left side we have two wires. One goes to the cabinet LEDs and the second one goes to the counter LEDs. For the counter we use a hold cap through which we can insert the wires without drilling.
If by any chance you want to extend the LED strip, you should check a few things. First of all, check if the power supply has enough power to support your additional LEDs.
So, once again, you have to calculate the total amount of power for the additional LEDs. As a reminder, it's the product of power consumption per meter and the total length of the LEDs.
Secondly, you'll have to find a compatible LED strip to one that you already have. So, check the voltage, the color temperature, the brightness, and especially the manufacturer. In some cases, you will find two LED strips with the same parameters but illuminate a little bit differently because the manufacturing process is different.
We've tried to cover almost everything about LED strips. However, if you think we've missed something or you really want to know more about something specific, you can always ask.
100% of the questions that you don't ask won't be answered.
Here is the kitchen before and after. Amazing how light can bring such a change. Thank you for watching!